Just of Ladyada welcomes.
Hi. This is this firmware you're looking for. Yeah, we're here. It's May 4th. We're back. Break time's over. Thanks to folks who were patient with our absence for a couple weeks. But we're going to do some catch-ups.
We put your tariffs.
Yeah. Well, it's been busy. Okay, so we are at the desk. We're doing all sorts of stuff. First off is, if you go to my computer, we have a shopping guide. That is...
Yeah, two things.
Star Wars related, prop maker parts, LEDs, buttons. That's a very common thing. We've got the Chewbacca mask, which lets you do props. We have like a lot of Noah and Pedro, of course.
There are tons and tons and tons. In fact, there are entire industries that use all the Adafruit stuff to make replica stuff for all of your favorite science fiction movies and more, including Star Wars universe.
And all the shows and spin-offs from there on. Okay, so we're back at my desk. Tariff's not over, but we're starting to work.
Tariff time's not over, lady.
It's not tariff, but I can't do anymore. At some point, it's like I keep telling people like prices are going to go up. I had to do a bunch of inventory management, rearranging where stuff is, where we buy stuff, trying to get some alternate suppliers. There's not much more I can do right now, so I'm
tune into our weekly segment, Tariff Talk. Ladyada will be doing some roundtable discussions. A couple media outlets reached out to her, so she's going to talk about it. And as of this week, a lot of the things are coming in, so we're going to be analyzing the tariffs. We're going to be publishing a lot of stuff.
Yeah, so, like everybody else, we just sort of stopped all shipments for like a week or two. Just
everybody did,
because it was like, what's happening? And then we're starting to get stuff in, and it's like they're getting tariffed. And the thing is that a lot of the parts that we sell, connectors, breadboards, wire, they're really not made anywhere else but mainland China. I would, if somebody has a supplier for breadboards that is made anywhere else in the world, I'd actually be into it.
I think, with all due respect, Ladyada, I do think we all eventually will get through that round of but surely there's a place somewhere that makes blah blah blah. There isn't.
Well, but there might be in the future. Maybe somebody knows. Right now, I haven't been able to find one.
Yeah, for some things, yes. For some things, no. Yeah. And we should all just be realistic about it.
Yeah, I will say, for example, espressif modules. They are only made in China. It's a mainland China company. They send stuff and sell stuff from mainland China. We were getting some ESP C5 dev boards and chips on the way, and they're like, "What's the price you're going to sell them at?" And I'm like, "Well, it depends on what they come in as. If you use this tariff code and it's valid, and it gets tariffed at this %, this is what we're going to sell it at. It's not going to be the $15 that you want us to sell it at, because that's more than what we pay for it after all the tariffs. But we'll do our best to make it as affordable and available as possible. It's a balance of, do I want to not stock things because tariffs, or do I want to stock things and make them more expensive? And some companies are choosing one over the other. Yeah. So we shall see.
Everyone's watching. Everyone's waiting. Do know that we would much rather be talking about how to get electronics in the hands of young people, how to do more open source code, how to get more hardware out there, how to solve some of the major problems in the world using science, technology, and more. It's also not fun thinking that there's enemies around the world because of this. Fully recognize it's called trade war. Yeah. So hang in there, folks, and we'll try to show a brighter path. I have one quick story that I think will give everyone a little bit of hope. There's moon rocks that the Chinese got from their visit to the moon, and they brought them back. And they told all the scientists in the world, these are for everyone, let's all work together. And the scientists are doing more together and showing how peace and free information exchange back and forth can really help. So there is some good going on. I had to do some good news for all of this. So yes, the governments don't like each other, but when it comes to science and technology, some of us can communicate with each other still for discovery and sharing. Anyways, I thought that was kind of neat.
Optimistic. Okay, so let's talk about some hardware we worked on this week, because we did start getting back into design. I want to get, we were doing a good pace of getting 2 Adafruit hardware designs in the store for a couple months there, and then we kind of went down to 1.
Everyone has a plan until they get punched in the face.
And then it was like 0, because eventually I ran out of stuff that was, again, components weren't shipped and stuff. Getting back into it. So the first up is I got the Sparkle Motion stick board done. So If y'all remember, I designed this around November when I did the other Sparkle Motion, and I did the Sparkle Motion Mini. We actually had a lot of yield issues with the Sparkle Motion. There was 2 things wrong with it, and they were both causing a lot of frustration. So we've been making revisions, and like sometimes the revisions fix the yield issues, and sometimes they don't. I think I know what to do. I think the next revision, like Rev F, will finally be done. But it's like 3. It's very unusual for me to have to do 3 revisions after something is released. Usually I only have to do 1, but I've had to do quite a few, which is annoying. But the ones in the store are working. Like we had them in stock. I think we have the WFL version. We'll get the antenna version. And then after the next round, I think I'm done. I think I've solved all the issues. So the Sparkle Motion stick, going to get that in. So what I wanted to do is use this off-the-shelf snap fit case, which I just thought was like so cute because it's translucent, which means the IR LED receiver will work. It's got a button, which I love because you can like switch modes, turn it on and off. For the ESP, you don't need it for entering bootloader mode, but it's just nice to have an extra button. And then there's a little area over here. We normally would have a USB port, but you can just have a PCB stick out, and then I have terminal blocks. And you can just attach your NeoPixels or dot stars on there. And the final thing I had to do is the microphone had to be moved around a bit, and I just tweaked the outline, but this is good. So I've booked the PCBs, and we have these cases in stock, actually, as a generic part. And I think this will be really nice. I think for portable projects, as funny as it's good for if you just want to plug something in at home on your computer and just have it, WLED NeoPixel. But the other thing that's nice is that this is good for portable projects where you just want to plug it into a USB battery pack, like those portable lipstick chargers, and then you can do your WLED project without needing to do any like LiPo management. All the battery management and boosting is done by the low-cost charger, and like these, you can buy them at grocery stores now. They're so popular.
Hey, Ladyada, since you're a lady, you just reminded me I had a note a long time ago for lipstick chargers, because that's what people call them.
Yeah.
They look like a little container of lipstick. Do you know if any lipstick manufacturers that are known ever made a charger that's lipstick and in a battery charger?
I mean, I think they probably like white labeled and off the shelf. They're much bigger than lipstick. They just look.
They look like it. Yeah.
They look like lipstick.
No, I thought that'd be neat if like one end was lipstick and the other end was a charger.
That would be useful.
Really?
Well, no, because then you'd have to replace the lipstick.
But yeah, you could like screw off and then that part would go in.
One. Somebody should do it.
Okay. Anyways.
Free
ideas here, lady.
Another thing is, so this is done, which is great, and this reminded me. I designed a while ago a bunch of these, like little. Actually wanted this to be for like home assistant or like home sensing, where it was like a little USB. This is just like kind of out of focus here. Let me see if I can. It's just so shiny, and this is like an ESP C3 or C6 or S3, whatever, and it plugs into USB, and it has the reset, and this is just the bootload mode, and it would have a couple of ports, and it would just be like, hey, you want to have like something that just plugs into your wall outlet at home, and you can add as an immediate sensor for your house, and maybe it would come with a sensor. I designed this like the minimal board. I was like, well, let's design the minimal, and I was kind of called it a Trinky. But I thought what would be neat is it's not that much smaller than this, and so maybe I would use this as an enclosure. I could still have that button. And then because it's actually hollow, like there's holes in it, you could have it as a temperature humidity sensor. Like I could add, I'd have extra space. We still have the button for putting it into reset mode or whatever. And then I'd maybe have terminal blocks, or maybe I'd have these ports for connecting external sensors, and they would come out the end here. So it would be very cute. And then, it could also have a TFT on the back, maybe. I don't know. So I think I'm gonna, I made like 4 versions of these just like really fast, and they all worked. But then I was like, well, what do I want to do with this? And I also wanted a case, and so this kind of solves the case thing. So maybe I'll use this as a case, because this case is, it's not too expensive. It's like $1 or $2, much cheaper than 3D printing translucent. Okay, so that's that. Then I also, I know some people were asking, the SEN-66 adapter. Which SEN-6X, which is slightly different than the SEN-5X. I got that working. This is the board, so it's 3 volt now, not 5 volt. Really beautiful sensor from Sensirion. We'll probably cover this on INPI when it comes back into stock. I happened to grab one from like the first like 10 that were available. They're slowly coming back into stock, and we'll cover it. And then we'll also have this board ready for people to use. It's nice because you just use a cable, you plug it in, and then you get I2C. It does the level shifting for you and everything, in case you're running it off of a 5-volt power supply. I mean, these components aren't that expensive. It just makes it very easy to plug into like a Raspberry Pi or Feather or Quick or Stemma or whatever. So that's coming soon too. Okay, let me see what else was going on. So I got the Sparkle Motion, the SEN thing. Okay, so the next thing, this will kind of sort of lead into the great searches. Okay, I'm finally going to get back to these Feather RP2350 Bones boards, right? Like I designed one and then like got punched in the face with tariffs. And I do want to get back to this, especially since the weather is getting better. And one of the things that I'm really looking forward to testing is, again, I've updated the charger to be, instead of the MCP 73831, which I've used on like 99% of boards, I'm using the BQ25185, which has solar input support. And that will be really neat because whenever people ask me like, well, I want to make like a solar Feather project, I'm like, oh my God, this is actually like really hard to do because it's like you have to design a board and like you can't make everything work. You have to make choices. And so I was like, well, I'm going to make it charge over USB and you have a battery backup and you have like, it's compact. I kind of just have to like pick, right? So I didn't pick solar because at the time there was no low cost small solar chips. But now this one is a little more expensive than the MCP, but it's not like crazy more expensive. And so I was like, well, let's experiment with having this series of boards come with solar support. So what's nice is actually the USB, which I'm going to actually have to change the name of this to be like I don't know. It's USB/VIN. And you would put your solar into here. But what I want to do, and then we can go to the computer, because I'll just like kind of design this really fast, is I wanted, even though you could just use a diode. Let's see, FeatherWings. And then let's find the INA FeatherWing, because that's kind of the closest. Do I already have a solar? Oh, it was a different solar. Hold on. It's I had another solar FeatherWing design. So what I wanted to do is I'm just going to like use this existing FeatherWing as the basis. How much time do we have?
Well, we've only done 13 minutes. So
okay, great. So I have like 5 minutes. So what I wanted to do, and then maybe I'll just kind of like erase this, is, it's always hard at 720p. Eagle is like so not designed for 720p. So I actually wanted to keep the INA 219. And then what I wanted to do is have a lot of solar panels have a 2.1 millimeter DC jack, or they can be adapted to. It's like pretty common. So DC barrel, and I thought I would just use a through-hole one. And then, ground is to ground. Just make sure, see. And then we need a diode. And so, traditionally, it's under breakout board, it's under battery and power, and it's under the what was it? The BQ, yeah. You need to have a diode in because first off, you don't want voltage going back into the PV cell. But also, there's a diode on the Feather board from USB, and so you want to have like a diode or power supply. And usually we have like a big ass diode here, like the SK34A. So I know this one is a nice Schottky diode. I'm just going to use that. And if you're wondering, yes, most of my hardware is now copy and paste. I don't actually have to do any engineering anymore. Okay, and then this goes into this USB because again, it feeds in. So if there is a solar panel plugged in and it's higher than 5 volts, which like almost, and there's no USB, or if there's USB, whichever one is higher will end up charging the battery. but then I was like, well, if I'm going to do that, and then like I think I would have the power coming like here, and then I don't have this little breakout area anymore, so let me clean this up. Boop. Okay, and then this diode comes here, and then I'll clean this up later, fix this up, reset button. And I was like, well, I want to have power monitoring as well, because one thing that is really common with solar projects, with me especially, is that I'm like, is it working? Like, and how much current is being drawn? And so I thought I would combo it. It's like if you're going to make a feather with a connector, you might as well like put some other stuff on it. So I thought, well, maybe I'll put on this INA 219 as well. And I would put it in between here. So this would be V plus, VN plus, and then this would be VN minus. I'll just kind of rename it. And then that would let me, I'd have maybe an extra terminal block if I wanted to, but I would use this to monitor the power with a big ass. Maybe like this, I don't know. Yeah, I'd route it out or whatever. And then over I squared C, I would monitor the voltage and the current of the panel, and it would let me know, like, it's common for IoT projects or for any like project. You're like, I want to know how much solar panel power I'm getting. So I haven't, you can see I've just like sort of sat down and decided to start working on it. So it's something like this. And, what's nice about the BQ25185 is it can use almost like any panel as long as it's more than like 4.5 volts. Which is like even kind of on a cloudy day, a 6-volt panel will be about a 4.5. And it will automatically adjust the current to get like the most power out of the panel. And then I thought with that INA 219, it would be kind of nice because then like you could also have like an external display if you so wanted that would tell you like which is the most optimal, like, you would actually be able to monitor live the power monitoring, and you can remove the display when you're done and you would know like, okay, this is set up in a place where I know I could get enough power throughout the day. So yeah, so maybe I'd keep the terminal block here, and this would be the alternative input. So you could have like hardwired, or you could have plugged in solar. There's a lot of empty space here, but that's okay. It wouldn't be a very expensive FeatherWing. It would just be like if yes, you could always use a diode, but you could do this instead. It would be like a little bit more advanced, and using this low cost voltage and current monitor, you can also see how your panel is doing. So I got to design that. I'm going to release a feather before that, but it's like I want to have this as I'm doing more advanced testing. So I might get the prototypes of this built, or I might like hand build a prototype. Like I said, it's whenever you're doing solar stuff, you always like it's very hard to know like, is it working? Because you see like the charging LED light up, but it doesn't say is it charging at 1 milliamp, 100 milliamps, or whatever. Okay, so I'm working on that today, maybe. Okay, so that's...
All right. Ladyada, I had one question for you.
What? Ask. Yes.
So is it because the inconsistency of the current, because the sun could be full blast or behind a cloud, that you need all this extra stuff to kind of like have some smarts? What's the main...
So the reason you want to have voltage and current monitoring is because you're not going to sit there like all day. Like, so usually solar panel installations are like a permanent install. And you don't, or not permanent, the same permanent, like you put it on top of your roof, or you put it on like the birdhouse. Or
like a tree, it's there for a while.
It's there for a bit, and you don't want to, and then there's like Sunseeker and other sites that can kind of tell you the optimal place and location. But like oftentimes you want to know long-term, like how much power am I able to get? And that's different than when you plug into a wall where it's like I'm getting 9 volts, 1 amp every time, like I know what I'm getting. With solar, again, it's like just because you're getting some power doesn't mean it's able to charge the battery. It could be like 10 milliamps. It's barely enough to get going. And so if, you know, especially with IoT projects where you might need to get the power to a certain level before you turn on Wi-Fi, which is going to like really deplete the battery, knowing like your range of how the power is going can help you with your orientation and location. So you put it in a location and then you can like plot the voltage and current, like on the Adalogger, you could just log solar panel and just be like, hey, you know, how's my power and current throughout the day? And then you could try 3 different locations and you're not sitting there like with like 2 multimeters, right? But it's really common. Like everyone I know with a solar install, like they have like a monitor that tells them like how many wattage did you get. And I think if you're gonna, the INA219 is very, you know, and I might use a slightly less expensive chip as well. And I'll talk about that in a second. You know, I think for an extra $3 or $4, you know, it's worth it to add monitoring to your solar setup. It's such a common request.
Okay.
Okay.
Well, is there any parallels between what happened in Spain and Portugal, where there might be so many things going on with power on a grid that was used to very consistent things like coal and nuclear, and then you have solar and wind? Because that was one of the theories. And
I think it was just a frequency mismatch. And if you get desynced, you know, every power system in the country has to be synchronized. If
well, you know that. I don't know if everyone else knows that. The audience watching
you
this
have to be within like 0.001%. Like you can't fluctuate because otherwise you have them fighting each other.
You know, one of the things that's a little bit of a drag watching the coverage is they probably need to explain like AC current and how it works, because it's like the conspiracies start right away because people don't have a lot of knowledge on how the electricity works, because it's been just going on for so long.
Thankfully, solar is DC. I mean, I think it would be more annoying if it was AC.
Yeah. Okay.
Okay.
What do you want to do next?
All right. So speaking of, let's go into the Great Search.
All right.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Every single week, Ladyada uses our power of engineering to help you. Yes, you find the things that you need on digikey.com. If you were in certain parts of the world, you might have been searching for a flashlight because there was a giant power outage, but maybe you want to have something to avoid ever being without power.
Okay.
Who knows? What are you looking for this week?
Yes. So this week I'm working on a new design for a little solar add-on board for my Adalogger, and I was just kind of crafting it live on Ladyada so people can see how much I copy and paste when I design. But if I've got 2 working designs, why not merge them, right? So
you're copying and pasting from yourself, so you should.
It's fine. So I've got you know, a DC power input going into a diode, and then what I wanted to do is add a voltage current monitor for the solar panel. And I was like all ready to be like, okay, let's route this board. This is going to be great. And then I realized, oh, you know what I actually really want is something to also monitor the battery, because I feel like if you're monitoring the solar panel and the current, I also want to see what the voltage is on the battery. And some of our feathers have battery monitoring built in, but a lot don't. And this one doesn't, especially. I couldn't fit it on. So what I thought I would do is I would look on DigiKey for a chip like the one I'm using here, the INA219, except instead of being a single channel, it would be a dual channel. And I would compare that to the cost of having 2 INA219s. Surprisingly, sometimes it's cheaper just to have 2 of like the same chip if you want like a dual channel, but you know, it'd be kind of cool if it was, if like maybe there's just magically one that's only like a little bit more expensive, can have 2 inputs, and then I can monitor the battery as well as the solar panel at the same time. So let's go to DigiKey. And so what's interesting is what I usually do is I actually start with a chip I've got, and then I'm like, find out what the category is, and then I look in the category for more chips. So in this case, what's interesting is it had a couple different categories. Like, oh, sorry, this is the INA2191, which is not what I'm looking for. I'm looking, which is just annoying. They don't have parts, have subparts names. Okay, this is the area where I found the 219. So, you know, the INA219, we've had this for like over a decade. It's one of our first breakout boards. It's a great little current monitor. fairly inexpensive. It's under $1 at high quantity. So I think, and they definitely want high side. So let's look. They're not really, this is the thing, that it's not really current regulation management. So, the thing is, it kind of gets thrown in with like a lot of different monitor chips. Another thing that was a little frustrating is that a lot of these, like this 168, which I've used, or the 169, is a analog input only. And I definitely wanted to be I2C. And then I was like, oh, well, what if like the 225 is a dual channel? Because like it has 2 in it. But this is also a single channel. And in fact, this is an analog output as well. So yeah, so I was like, uh-oh, this is, sometimes the DigiKey search is like perfect and has everything you need. But in this particular case, it didn't actually have a way to filter out the components. And you're not abandoned, right? So, don't freak out. There's still a solution. So what I do in this case, and this is particularly in the case of when you have a sensor or chip where you want something similar or like in the same family, what I always tell people to do is like, well, go to the product page at the company that makes it, whether it's like Renesas, TI, Analog, Maxim, National Semi, or any other non-existent company. And often they'll be like, okay, there's similar devices. And also they usually have their own search. Now, obviously, so they have 2. There's ones with integrated shunt, ones without. We can search for both. Let's do the ones without, because usually those are a little less expensive. So what we can do, there's a lot of like, okay, you can search for like different bit depths and automotive and precision. I don't actually care too much about precision. So in this case, I'm going to say show all. And then what's nice is I already know that these are all voltage monitors, and you can search by number of channels. So I can have this filter. In this case, there's no option for 2. They just don't have a 2. But I'm going to select 3 and 4. And in this case, there's a couple options. They do have this thing called the price per quantity. I'll always warn people that check the DigiKey price. This price is often a little, it's not always correct. Sometimes it's fantastical. It doesn't always reflect reality. But in this case, it's like, okay, the INA3221, which I've actually used before, and it's like, they're saying it's about $1.30. So if I go back to DigiKey and I just check, make sure that they have it in stock, and looks like they do. I'm just going to select the active because they have a couple versions. And yeah, like I said, it's that $1.30 is a little optimistic, but it is like $1.80, which is about the same price as 2 of those INA219s. So I'm not 100% sure I'm going to go with this, but let's also, while we're here, let's look at these the power monitors with the integrated shunt resistor, because you never know. Sometimes they have something here. So let's search, and again, let's go over to resolution bits. Do they have channels? You actually didn't actually check this. I don't believe they have any. I think they're all single channel. Yeah, these are all single channel boards. So they don't have any dual channels. That's what it is. So this is kind of my option. Not sure yet. On one hand, altogether, look, you have to pay for the cost of picking a component. This part is a little bit expensive. It'll add a couple bucks, but I think it's worth it for people who want to be able to monitor both the solar panel input and the voltage. What I might do is I might make a version of the board that has the monitoring and one without, and to be like, look, if you just want like the diode and the connectors and that's it, without the monitoring, cool. If you do want the monitoring, it'll probably be another $5. And I think most people will want it, but if you really want to have the lowest cost version, it'll probably be only a couple bucks. So this is what I found for more than 2 channels, 2 channels or more of voltage and current monitoring for my solar board.
That's a great search.
Where in the world is that part I need? The great search with DigiKey.
All right. And obviously, if you were on another planet,
Yeah.
you would need, like, this wouldn't work on Mars, right? Because the sun is different. Or even if there was two suns on a planet, you'd have to.
I don't know. I mean, solar must work on other planets.
I
Because
know, right? You know what's neat?
We
Is
have
it-
rovers, and I don't think they run on nuclear. I think they run on solar.
No, I'm just saying, like,
They get dust on their panels.
Yeah.
That's the problem.
so when you're doing solar stuff, I guess there's a version of this type of process or chip or something for when you're on Mars.
I think it's less efficient
Yeah.
because of the distance
Yeah.
and maybe the atmosphere. But I think solar panels still work.
It'd be neat to have like a library of all the hardware that goes on other planets, because you could go and check like, oh, how do they do solar? Because like it's a little different over there.
Nice. Check in with Europa next week.
Yeah, we
Okay.
will attempt no landing there. Okay, everybody, that is Desk of Ladyada. See everybody next week.
Bye,
Bye-bye.
everybody.